Alright guys, welcome back to a new semester. Let's dive in here. Did you guys know who invented cotton candy? A dentist. No joke. That dude was just getting job security. Alright, so we're in a new unit here, Systems of Equations, and today's video is an intro to systems. So you guys kind of get the idea of what we're doing. I want to lay some groundwork so you know where we're at, where we're headed, and the next week's worth of lessons will actually make sense. Let's dive in. All right, systems of what? Let's look at this. What you know. We already know how to solve equations, right? That's a basic two-step. I know I can just cancel to solve this guy. Simple and done. We know how to solve equations, and the important thing here to notice is it's got one variable. If there's an equation with only one variable, there's only one value that will make that equation true. If you solve correctly, that's the value you find. Okay? If, in other words, we plug that -4 in, we go back to our original equation. And we plug that guy in, okay, this is checking the -4 as a solution. And if we do that, what do we see? Oh, we see that 12 plus 2 does equal 14. We've got the right solution. We know how to do this. We know how to find a solution to an equation when there's only one variable. Okay, what else do we already know? We've got this -3x plus 2 equals y. We know how to graph that. First of all, I'm going to put some marks onto my XY axis so I can graph. Try to keep them equal because we need that. And we see here that that is my B, which is the y-intercept. And right here next to x is M, which we know is our slope. So we know if we have the equation, and notice that is important, if we have the equation solved for y, then we call that slope-intercept form. At the end of the last unit, we started seeing them in another form called standard form, and you'll see that a lot more. But this is slope-intercept form. If it's solved for y and y is by itself, that lets us see the slope and the intercept right in those two positions where the M and the B are. And then we can graph it really easily. B, y-intercept is at 2, so I go up 2, there's a point. Take my slope, which is -3, and we can just make it over 1. Remember, any whole number over 1, so we go down 3, over 1, there's my point, and there's my line. Okay? So you guys already know this stuff. We know how to solve an equation if it's giving us one variable, and if it gives us two variables, we know we can turn it into a line. Now in terms of solutions, when we've got this line, we can take any point off that line. That point is 0 for the x value, 2 for the y. Or we can take this point, and that is 1 for the x value, -1 for the y. And we can also plug those into the original equation and check to see if they are solutions. Okay, so we can take our -3x plus 2, and I can just plug in this first point right here. The x was a 0, the y was a 2, and we can check to see if this works. And yep, it does. We could do it with the exact same position of the other points. -3 times x value of 1 plus 2 equals the y value of -1. Let's see if it works when we plug those in. -3 plus 2 does equal -1. So we've got two solutions in that they make the equation true. And the thing is, how many of those solutions are you going to have on this line? How many points do you have that you can plug into that equation and it's going to make it true? Hopefully you guys are saying, duh, Mr. A, infinite. because every point you can find on this line, wherever it would be on the x and y, they are all going to make that equation true forever. So we know how to graph, we know how to solve in one variable, but notice the idea of solving in two variables, this idea of solutions with a two-variable equation, we can do it, but boy, there's a lot of solutions, an infinite number in fact. All right, moving on. Okay, what is this idea of a system of equations? Well, a system just means more than one. And what are we talking about here? We're talking about equations. Okay, so a system simply means more than one. Right now, we're going to be dealing with systems that have two equations. And when you guys get to Algebra 2 later, you'll be dealing with systems of equations that have three equations. I bet you're looking forward to that. These bad boys literally take an entire piece of paper to do one problem. They're fun. Okay, when we talk about equations, what are we talking about? We're talking about an equation in two variables. Which you guys are already familiar with. It's just your x and y, okay? Which means they can all be graphed. And these are all linear equations, so they're all going to graph as lines. All right, so let's take a look. Let's look at one. Here's an example system for you guys. Okay, and up here on the left, this is Desmos. Here's our two equations. Let's get that out of the way. These are the two equations we just graphed. Notice they're both in slope-intercept form. They're both solved for y. They both have their slope and their y-intercept, and they were just simply graphed. Could you tell me what you think the solution to this system is? I hope somebody, actually I hope many somebodies, are saying, yeah, Mr. A, it's pretty obvious. It's that point right where the two lines cross. And if that's what you're saying, good, you're on track. What point is that? It's got an x value of 4. It's got a y value of 0. And that particular point can be plugged in to both of these equations. Negative 1/2 x, we said an x value of 4. Plus 2 equals y, we said a y value of 0. Half of 4 is 2, don't forget the negative, so negative 2 plus 2, yep, it does equal 0. And if we plug it into the other equation, I bet you know what you're going to see in a minute. Okay, in this one, note, it's just like a fraction buster. We're multiplying and dividing by the same number. So that's the fraction buster concept. They're just going to cancel each other out, and that 3 is left over by itself. 3 minus 3. Yep, that does equal 0. That's a solution. That is the whole idea of a solution to a system of equations. The two equations you'll be given will always be lines, and there will be a single point where they cross, and that is the only point that is a solution to both equations. We could pick this point and plug in that value, that's a 0x and a 2y. That solution will work for the blue equation, but it will not work for the brown equation. It won't be true, it'll be a false final statement when you plug it in. The same thing, we could pick points off of this, if I could find another point I could see on the graph, we could pick some other point on the brown line, and it would work for the brown line as a solution, but not the blue. So that, in a nutshell, is the next unit. Given two equations, you need to be able to find the single solution to both of them, which is the point that's on both lines. All right, solving a system. To solve a system means find the x and y value that together are the solution to to both equations. That's the thing. It's got to solve both of them, make both of them true. Okay? And then the fact that, I'm going to keep writing down the side here, the x and y make a point. All right, x and y, you can always graph them as a point, and that'll be the point where both lines crossed. Okay, that's the big picture here. That x and y value you find, if you graph them as a point, they're going to be the point where the two lines cross. So in a sense, I already taught you one of your methods today. There are actually 3 methods you can use to solve systems of equations. Algebraically, there's one method we're going to learn, and that's called substitution. There's another method with algebra called elimination. And when I say algebra, I mean no graphing. For those of you that feel this way about graphing, I have good news. You don't have to graph at all. You can just use substitution or elimination and be a perfectly happy math student, no graphing, and still ace the quiz. If, on the other hand, you're someone who likes graphing or sees the ease which with you can use it, that is our third method, and you can also use graphing to solve all of your equations if you would like. I'm going to introduce all 3 methods. You guys are going to be free to pick the one you want to use, but there are going to be times when each of them is easier to use than others. If you always stick with graphing, you're going to run into some rough challenges on some of your problems. If you only use substitution, you're going to run into some tough challenges at times. So you really want to learn all 3 of them to some degree and be flexible. That's going to be your best bet. Okay, graphing we've already seen. You got 2 lines crossing each other, something like that. All you have to do is graph them and find that point where they cross, and that's your solution. Substitution and elimination, we're going to get to a little more in upcoming videos, but the basic idea, you know what? No, I can't get into the basic idea. I'm going to have to give you the whole video at once to make sense of it. All right, we're going to call it good there, and I'll give you some practice to get you going and prep for this unit. One sec. All right, guys, here's your homework. Number 1, solve that system using graphing. Just like we talked about, it's something you already know. You've just got 2 lines on the one graph. And don't remember, identify your solution. The whole point of this is to be clear about what the solution is, so when you find it, write it up as a point, okay? Circle it. Make it clear when you have a solution. Number 2, is the given point a solution? Remember, you've got to plug it in. It's got to be true in both. It's got to make both equations true to be a solution. Number 3, solve. Just some good old practice, because you guys need to keep your equation solving skills up.